Hi, I'm Dr. Papia Bhattacharjee. In this problem, we are given a P series, sum 1 over n cube. It's also given that if you take the difference of the actual sum of the infinite series and a partial sum, Sn, that difference is not greater than this quantity. It's less than or equal to this particular quantity. Now, we have to first approximate the sum using the fourth partial sum, S4, and then we have to find the maximum error of that approximation. Okay, so let's first compute S4. Now, do you remember how to compute the partial sums? Since it's S4, since n is equal to 4, that means we have to add the first 4 terms of this series. Okay, so which means we have to add A1 plus A2, A3, and A4. Now, what is A1? So now look at the expression inside this summation and then plug in n equals 1. So A1 is 1 over 1 cube. Then A2, plug in n equals 2. So 1 over 2 cube. A3 is 1 over 3 cube. And then A4, 1 over 4 cube. So sum of these first 4 terms will give us the fourth partial sum for this series. Okay, so let's calculate this sum using a calculator. Okay, note that the first number is just 1, and then 1/8 and so on. Okay, and the sum is approximately 1.178. So, since this is a partial sum, and you compute all these partial sums, and the limit will give you the actual sum of this particular series. So we are approximating that sum. So the sum, if you call it S, is approximately equal to its partial sum, 1.178. So that's how you can approximate the actual sum of a given series. Okay. Now for part B, we have to find the maximum error of approximation. So this is an approximate value, and we don't know what the actual sum is. So how do we find the error? What is error? Remember, error is the difference between the two, right? The actual sum and the approximate value. And we are given that, see, the difference of those two values, which is the error, is not bigger than this quantity. So to find the maximum error that we can have is this particular quantity. So all we have to do is plug in P and N, and then we can get our maximum error. So max error is going to be 1 over P minus 1 times n to the power P minus 1. Okay. Now think about it. What is P? Remember, this is a P series. P is the number that's in the exponent. So this is P. So P is 3. And we need to know what is n. Well, we are finding the maximum error for this particular partial sum. And n is 4 because we're using the fourth partial sum. All right, so let's just plug those values in. So this is 1 over 3 minus 1 times 4 to the power 3 minus 1. And that is 3 minus 1 is 2, and 4 square, so that's 16. So 16 times 2, that's 32. So this is the maximum error of our approximation of the sum, 1.178. That completes the problem. Thank you.